Hello students, welcome you to this session. In this video, I am going to teach MCQs, that is objective questions from chapter number 8, that is sampling techniques and statistical inference. Okay, it's a very simple topic but lot of theory part. Read the textbook thoroughly because any line can be asked as a question, try to understand, and lot of theory questions also there. It's important for 2 marks, 3 marks also. Then major 5-mark question, testing of hypothesis, very simple thing, just 4-5 steps, right? Form H0, then H1, choose the test statistic, right? Is that equal to, the formula? Then that is the calculated value. Then find the table value using the level of significance, right? Then you compare. If the calculated value is less than table value, you accept it, accept H0. If not, reject H0. Then finally write the inference, that is the conclusion you write. Okay, so now let's move on to the objective questions. The first one, a dash may be finite or infinite according as the number of observations or items in it is finite or infinite. A dash may be finite or infinite. The correct answer is what? The population. The population means we are going to study about which one. Suppose the 12th standard students interested game, then all the 12th standard students together, it is a population. It may be finite or infinite. Okay, so that's a population. Next one, a dash of statistical individuals in a population is called a sample. What is a sample? To study about the population, we have to collect data. From whom you collect? You may not be able to collect data from the entire population. If the population is infinite, not at all possible, right? So we take a representative part. We need a finite one, and that is called sample, right? A dash of a statistical individuals in a population is called a sample, a finite subset. So you have to take a sample from the population. So it should be the subset and it must be finite. Okay, the finite subset. The finite subset from the population is called sample, or you can say sample is the finite subset from the population. And that is the third question, just the reverse one, right? A finite subset of statistical individuals in a population is called sample. Same thing, the previous question, this one, just in the reverse order. Okay. Any statistical measure computed from sample data is known as. Any statistical measure, normally we measure here mean and standard deviation, right? Sample mean we denote it as x bar, sample standard deviation we denote it as s. Population mean we denote it as mu, and population standard deviation we denote it as sigma. Then variance means sigma square. Okay, these measures, these statistical measures has a special name. If they are the statistical measures of population, we call them as parameters. So mu, sigma are parameters. Whereas the statistical measures are computed from sample mean, that we call it as statistic. So any statistical measure computed from sample data is known as statistic. Suppose instead of sample data from the population, then your answer is parameter. Okay, so read the question carefully. Don't try to mug up. When you go for the examination, if the word is changed, the answer change. You may lose your centum, right? You have to be very careful. Read the question carefully. Now let's move on to question number 5. A dash is one where each item in the universe has an equal chance. Equal chance, that is some probability, right? Unbiased. So equal, chances are equal. So it should be a random sample, right? Then question number 6. A random sample. What is a random sample? So a lot of statisticians given definitions, and this definition, a random sample is a sample selected in such a way that every item in the population has an equal chance of being included, is defined by Harper. Okay, just remember that. The next one, which one of the following is probability sampling? probability sampling, that chances must be equal, right? So purposive sampling, judgment sampling, convenience sampling, no, it should be simple random sampling. Okay, chances are equal. So probability sampling, it is simple random sampling. Now let's move on to question number 8. In a simple random sampling from a population of n units, the probability of drawing any unit at the first draw, totally there are n objects. Suppose assume there are 5 objects. What is the probability of selecting one? 1 by 5, right? You are throwing a die. 1, 2, 3, 4, 5, 6. What is the probability getting a 5? 1 by 6, right? So here there are n observations, right? In simple random sampling from population of n units, totally n units, the probability of drawing any unit, that is you are taking 1 unit, okay? The first draw means all the n units are there. Second draw, suppose 1 unit, you take it, if you keep it outside, then the second time it may be only n minus 1. It will be only n minus 1, then 1 by n minus 1. Here there are n observations, so the probability of drawing any unit is 1 by n. Now let's move on to the next one. In dash, the heterogeneous groups are divided into homogeneous group. So there are different types of samples, right? So a heterogeneous group is given. So we divide it into homogeneous groups. We divide it into several homogeneous groups. From each group we select some sample and form a collection, and that is called stratified random sample. Okay, so that's very important for short note also. A stratified random sample, what it is? In stratified random sample, the heterogeneous groups are divided into homogeneous groups. Okay, so then question number 10. Errors in sampling are, there are 2 types of errors, right? There are 2 types of errors. So the answer is 2. And what are the 2 types of errors? Type 1 and type 2. That also some object is given here. Type 1 error. We are rejecting H0 when it is true, right? H0, the hypothesis what you are assuming is true, but still we reject it. So rejecting H0 when it is true, that is type 1 error. Type 2 error, accepting H0 when it is false. Okay, so that is type 2 error. The order also important, okay? Then question number 11. The method of obtaining the most likely value of the population parameter using statistic. The method of obtaining the most likely value of the population parameter using statistic is called, the process they asked, and it is called estimation. Now question number 12. The estimator in a sample statistic used to estimate a population parameter. Population parameter may be population mean, population standard deviation, right? To estimate that, the sample statistic, it is used, an estimator is a sample statistic used to estimate what population parameter. Question number 13. Dash is the relative property. There are 4 relative properties that given us what? The choice, efficiency, sufficiency, unbiased, consistency. So short note also it's important. Dash is a relative property which states that one estimator is efficient relative to other. One estimator is efficient relative to another. The name itself it is there, efficient. So this property, this relative property, we call it as efficiency. Then let's move on to the next one. Question number 14. If probability P of modulus theta bar minus theta less than epsilon tends to 1 as n tends to infinity for any positive epsilon, then theta cap is set to consistent. Just remember this definition, consistent estimator of theta is only for short note, okay? So we don't have any sums based on that, okay? So take it as a result and learn. Now question number 15. An estimator is said to be dash if it contains all the informations you have. So what the information you have is sufficient to us, right? So this is called what? In the data about the parameter estimates is called what? Sufficient. Okay. An estimator is said to be sufficient if it contains all the information in the data about the population, about the parameter it estimates. Now question number 16. An estimate of the population parameter given by two numbers between which the parameter would be expected to lie is called an dash interval estimate of the parameter. So the answer itself, interval estimation. You know, in estimation there are two types of estimation: point estimation and interval estimation. Point estimation, we estimate the exact value, right? One point, just give the one value we are giving. That is point estimation. Interval estimation means we give an interval. It lies between this and this, right? So that is what given here. An estimate of the population parameter given by two numbers between which the parameter would be expected to lie. So it is called interval estimation. Now question number 17. A dash is a statement or an assertion about the population parameter. It's a statement. Okay, it's an assumption about the population parameter. Population is an infinite one, right? It may be finite or infinite. So you cannot arrive a conclusion about that directly. So we assume something, right? We have population mean is this one, or population standard deviation. We assume, then we test it, right? So, and that statement is called what? Hypothesis. Now let's move on to the next question. Type 1 error. Type 1 error. That is, when H0 is true, we are rejecting it. That is type 1 error. It is true, we are rejecting. So, type 1 error, right? When it is true, reject H0. C, right? Reject H0. H0 is the null hypothesis. So, it is true, but we are rejecting. So, that first one is C, accept H0 when it is true. There is no error, right? Accept H0 when it is true. It is true, we are accepting. Yes, that's good. There is no error here, right? Accept H0 when it is false. There is an error, right? Accept H0 when it is false. It is false, but we are accepting. That is an error. This is actually type 2 error. Reject H0 when it is true. There is an error, right? Reject H0 when it is true. There is an error. That is type 1 error. Okay. Reject H0 when it is false. H0 is false. False one should be rejected, right? H0 is false and we are rejecting it. There is no error. Okay. So you must be thorough with everything, right? So here type 1 error they asked. So reject H0 when it is true. Let's move on to the next question. Type 2 error. What is type 2 error? Accept H0 when it is false, right? So first option, accept H0 when it is wrong. And the last question, the standard error. So you would have used in many places, even when you calculate test statistic, right? Is it equal to x bar minus mu by what? Sigma by root n, right? This is standard error, sigma by root n. If sigma is not given, we use s, right? S by root n. Then in confidence interval, there also we use this standard error. So standard error of sample mean is sigma by root n. So C is the correct option. Okay. So that's all the objectives given in your book. But what I'm encouraging you, read the book thoroughly so that you can answer any question. We'll continue in the next video.